Hello and welcome to Empowered Learning. This video will be about solving linear inequalities. So the main thing that I want to stress here whenever we solve linear inequalities is that the process that we use to solve them is going to be very similar to solving a linear equation. If you're not familiar with how to solve linear equations, then I encourage you to go watch the video that I've made on that, solving linear equations, to kind of get you up to speed on that, because you do need to know that information before you watch this one. So the one thing that is different about solving linear inequalities versus solving linear equations in the procedural part of it is that whenever we're faced with a situation where we have to divide or multiply both sides by a negative number of an inequality, then we have to change the sense of the sign, or simply we have to flip the sign. So as a short example here, let's say if I have 2 minus 5x is less than or equal to, let's say, trying to think of a number here that'll make the math easy. So let's say 12. Okay. So here I would need to get x by itself, so I would need to subtract both sides by 2x, and that would end up with a negative 5x, which is less than or equal to a positive 10. And so now, in looking at this, I need to get x by itself, so I have to divide both sides by a negative 5. Okay. Now, with equations, you would just go off and say that x is equal to negative 2. But since we are dividing by a negative number here, we have to change the sense of the sign, meaning instead of having less than or equal to, I have to have greater than or equal to, and then have a negative 2 there. Now, if you're unsure of where you actually have done that correctly or not, you can always go back and check. So, for instance, here I'm saying that as long as I have values of x that are 2 or higher, then when I put that value of x into this equation, into this inequality here, I am going to get numbers on the left side that are going to be less than or equal to 12. Okay. Now to test that, let's say I want to plug in or evaluate the left side here with a number that is less than negative 2. Okay, so let's say I plug in a negative 3. Negative 3 is less than negative 2. If I do that, then this is what I get. And I know that negative 5 times a negative 3 is a positive 15. And notice here that 2 times 15 is 17, and that this statement that I've just written here is not true. It's a false statement. 17 is not less than or equal to 12. 17 is greater than 12 by a long shot. Okay, so this is the reason why we have to flip the inequality sign to make sure that all the math sort of works out. But other than that, everything else is very similar to solving linear equations. When we get to compound inequalities, then we'll talk about some of the nuances with that, but we'll start off with some simple examples here. Now, we will also be answering these questions in what we call interval notation. And so if you are unfamiliar with that, I would encourage you to watch my video on interval notation to be caught up on that information as well, because you'll need to know that to be able to express these answers in that form. So for this first example here, we just want to solve our inequality for x. So I'm going to subtract both sides by negative 1. That's going to make that go to 0. And we have 5x minus 6. And then we want to get all the x terms on one side. So I'm subtracting both sides by 5x. That gives me 3x here minus 6, because that cancels to 0. And then here I need to divide both sides by 3 to get x by itself. And so x is going to be any number that is -2 or higher. And if we express that in interval notation, that looks like bracket -2 on to infinity. For example B, the first thing that we need to do is combine like terms. So 5y plus y is 6y minus 5. And over here, 2 minus 8 is going to be a -6. And then we just bring down the -6y. So at this point, we need to get all terms that have y's on one side, everything else on the other. So since I have this -6y here, I would like to get it over to the left side to make everything positive. So to do that, I'm going to add 6y to both sides. Okay? And that gives me 12y minus 5 is less than or equal to -6. And since I want the 12y over here by itself, I need to add 5 to both sides to get rid of it. And so 12y minus 0 is just going to give me 12y. And -6 plus 5 is a -1. And then we finish up by just dividing both sides by 12. And we see that our answer here is y is less than or equal to -1/12. So in interval notation, that will look this way. All right, let's move on to some other examples. All right, so for example C here, we notice that we only have one term that has an x in it, so we can leave this on the left, but we have to get rid of this 2. And so we'll do that by subtracting both sides by 2. That cancels to 0, and we just have -3x, and -4 minus 2 is a -6. And so now, whenever we divide, notice that we are dividing by a negative number. And so with inequalities, whenever we multiply or divide both sides by a negative number, we have to change the sense of the sign, which means we have to flip the sign. So instead of doing this greater than, now it is less than. And so -6 divided by -3 is a +2. So values of x that are less than 2, if I were to plug it into the x here, it would produce values that will be greater than -4 over here. So that's essentially what we are finding when we do these inequalities. In interval notation, this will look this way. Now, for example D, this is an example of what we call a conjunction, which is a compound inequality. And a compound inequality is just an inequality statement that has 2 or more single inequality statements in it. And so what this actually says, this is the abbreviated form. What it actually says is that has this inequality statement and this one being satisfied at the same time. And I'll explicitly write that out. So it says x plus 2 is greater than -3 and x plus 2 is less than or equal to 5. Okay? So here you're saying that the values of x will be such that they satisfy both of these inequalities at the same time. And so I'm going to work this problem out this way, but then show you a shorter way to do it whenever we have it in this the form that we're given. So here to get x by itself, we just subtract both sides by 2, and we have x is greater than -5, and here we subtract both sides by 2, and here we have x is less than or equal to -3. And so what this says here is that we need to pick the values of x that satisfies both this condition and this one at the same time. And so what I'm going to do is pause for a moment and draw what both of these mean and show you where the numbers that satisfy both of those conditions lie. All right, so now that I've drawn this graph here, what is in the red represents what is going on with this one, which is values of x that are greater than -5. What is in the green goes along with this one, which is all the values of x that are -3 or smaller. And so the values of x that satisfy both of these at the same time are actually all these numbers that are in between here. So all these numbers here. So when I'm drawing right here, all the numbers that are above -5 but less than or equal to -3 are actually the numbers that satisfy both of these. So if we want to write this answer in interval notation, it will actually look like this. So parentheses -5, comma 3 with a bracket. Okay. Now, this is the hard way to solve this problem, but I did this so that you understood conceptually what is going on. Since this is a conjunction, and we know that because we have small number to large number in the signs, I like to call them mouths, eat from left to right. Since it looks like that, we know we have a conjunction, and thus the simple way to do it is just to subtract 2 from all sides of the inequality. So I'm going to erase what I have here and show you how we could have gotten the same answer just simply by doing 2 steps. All right, so if we do this the simple way, we can just subtract 2 here, subtract 2 there, subtract 2 there. And of course, this is -5, cancels, and you just have x have less than or equal to 3. And so we see that x is strictly in between -5 and 3, including 3. So we can write this answer this way. Okay. All right, so for our next example here, notice how we have a compound inequality, but we have x on more than just one side of it. So because of this, we're forced to have to write this out as 2 separate inequalities. So we will have to write this out as x plus 5 is less than 2 minus 4x, and 2 minus 4x is less than or equal to 16. And we have to solve this inequality. So to do this, we'll add 4x to both sides here. That cancels. We'll have 5x plus 5, and that is less than 2. And we'll subtract 5 from both sides here. Of course, in doing that, that will cancel. Oops. And we just have 5x is less than -3. And then, of course, if we finish up here, divide both sides by 5, we'll get x is less than -3/5. On this side, what we could do is subtract 2 from both sides. And then 16 minus 2 is 14. And then divide both sides by -4. And of course, in doing this, remember we're dividing by a negative number, so we have to flip the sign. And of course, 14 divided by -4 will reduce to 7 divided by -2. And so now we have x has to be less than -3/5, and on top of that, x has to be greater than or equal to -7/2. And so in decimal form, if you don't recognize this, this is just saying x has to be less than 0.6, and it has to be greater than or equal to -3.5. So if we were to draw that, the -3.5 would be here, the -0.6 is here, and we're saying that we're all in between these numbers here. where the 0.6, we can't include that, but the 3.5, we can. And so the answer here just ends up being -7.5, 3/5 with the parentheses. All right, and I think we need to put that negative there. And so now let's go ahead and move on to some of our other examples here. So starting with example F, we're dealing with what we call disjunctions. And we know that we have a disjunction because we see this word or in between here. And so to compare that to a conjunction, what a conjunction is we're taking the intersection of two single inequality solutions here. And I'll go back to our previous example to make that point. So let me go back here. In the case of D, if you remember, we actually had two things that we were saying. We said X had to be greater than -5, and on top of that, we said X had to be less than -3. So we were trying to find the intersection of these two solution sets. So that's what a conjunction is. Now, a disjunction is just the opposite of that. We have two sets of X values for a solution, but in this case, they're separated. So there's a gap in between one solution, one set of solutions and the other. And so what we want to do is add or join them together to make them one, since there's some separation in between it. So I'll go ahead and scroll back here to example F to make that distinction here. Now, the proper way to write a disjunction is to write it as inequality or, and then other inequality. There are other ways that you could possibly try to do this, but that notation would be incorrect. So this is the proper notation for disjunction. So now that you know that, if you have any problems to where you are looking at it this way, you know that you need to write all disjunctions in this form. Now, to solve them, relatively easy to do. We just solve each single variable inequality on its own and figure out what the answer is. So for this first one here, of course, we need to divide both sides by 3, which will give us X is less than or equal to -2. Or here we just add 1 to both sides, and we see that X is greater than 1. And so if we were drawing that on the number line, it would look like this, where X being greater than 1 will go this way, and X being less than or equal to -2 will kind of look like this and go this way. Now, how we would express that in terms of interval notation, we'll say X is equal to -infinity to -2 with a bracket. And then we use this set theory operation called a union. And the union just says, I want to take this set and add it to this one. And so that is how we would properly express our solution set here for this disjunction. All right, let's move on to example G. So for example G, of course, we do the same thing. Just solve this in your inequality. We'll subtract both sides by 11. And then here we will divide both sides by 5. Now, do we need to flip the sign here? So if you answered no, then that is correct. Because again, we only flip the sign whenever we are whenever we're multiplying or dividing by a negative number. Since we actually divided by a positive number, we do not have to change the sense of the sign or flip it. So we see here that in this case, X is going to be less than or equal to -3. Okay. Now, of course, we bring down our or. Now we do this again. And in this case, we know 4 minus 11 is a negative 7. Make sure my line is there. And then here we divide by 5 again. And of course, x in this case will be greater than or equal to negative 7/5. And in decimal form, negative 7/5 is like negative 1.4. So just what you know what that looks like from a decimal number standpoint. So again, if we were drawing this on the number line, this would look something like this. And in this case, we would have brackets going like this, going this way, moving forward, and we would have brackets going this way there. So this takes care of the x is less than or equal to negative 3. This takes care of the x is greater than or equal to negative 7/5. And remember, this is like 1.4. And so now, if we want to write that in interval notation, it just looks as follows. All right. So now let's move on to example H and example I. So these two examples are put here to make sure that you really do understand conceptually what is going on whenever we have a disjunction versus a conjunction. So if you remember here, if we have two inequality statements and there's a word or in between them, we have a disjunction. So if we solve these, we'll do it just like how we normally do. Subtract 18 from both sides. And 12 minus 18 is a negative 6. And then we divide both sides by 3. And this ends up being x is greater than negative 2. Okay? Or, and now we do same deal here. Subtract both sides by 25. We just have 5x. 40 minus 25 is a positive 15. And we divide by 5 again. And we get x is less than 3. So here we want a number for x to be either greater than negative 2, or we want it to be less than 3. And so if we look at this, on the number line, this is what we're actually saying. We want, and I'll just go ahead and draw it first. So this is the x is greater than negative 2, and this is the x has to be less than 3. So what we want is the values of x that either come from this set or this set of values. And what you'll notice here is that as long as we pick from one, it could be in this final solution set. And so I'm going to go ahead and write this out. Like this, and this is or. But notice that the way that this looks, if I pick a value of x from here, or I pick a value of x from here, notice that I'm covering the whole number line. In other words, if I pick a value of x from here, as long as I pick a value that is less than 3, I'm good. Or means I can go from here, or I can pick a value of x that is greater than negative 2. And so all of the real numbers would be a number either greater than negative 2 or less than 3. So here when we OR these together, we basically just combine these two sets together to make it one. And since there's no separation in between them, they actually overlap. What that means in this case is that the answer to this is all real numbers, meaning that any value of x we could plug in here, and we would get these conditions satisfied. Okay. Now the difference is in between this example, which is the disjunction, and this one, which is the conjunction, is if we do the same thing, then we'll get the same results here. So I'm just going to rewrite all this. But the difference now is the word and. So we do all this. Let me see, we get 5x less than 15, divide by 5, and x is less than 3. So here what we want is the overlap of both of these sets, or put another way, what these two sets have in common. And so in this case, we're looking at what this set and that set have that is the same. And what you'll notice here is that all the values of x that are in between -2 and 3 are in common, or is in the intersection of both of these sets here. So that means that all these values here, all in here, stopping here right before -2 and stopping here right before 3, would be the values that satisfy this condition and that one at the same time. So essentially what this means here is that if we're writing this answer in interval notation, this is just going to be all the values of x strictly in between -2 and 3. And this is how we would write it. And the orange graph here is how I would draw that on a number line if I were trying to describe that. So I hope that through these examples, you have a clearer understanding on what linear inequalities are, how to interpret them, as well as how to go about finding out what their solutions are and to express them in interval notation. Hope this has been of help, and I'll see you again on the next video. Take care.